Welcome back, everyone. Dan Vega here, Spring Developer Advocate at Broadcom, and today we're going to be talking about some performance optimizations we can make when building out GraphQL APIs in Java and Spring. Now, I've been talking a lot about GraphQL over the last few years. I'm a big fan of GraphQL, but recently I gave a talk at CodeMash 2025, and I did a little bit of a live coding session where we went through building out GraphQL APIs in Java with Spring for GraphQL, and we talked about some performance optimizations. I want to go over those today. Mainly, we're going to focus on two. We're going to focus on the N+1 problem. So we'll have an example today of where we have an author and we want to get an author's books. So for every single author, we need to make a call out and get all of those books. This is going to be the N+1 problem. We're going to talk about a couple different ways that we can solve for this. Another is by taking advantage of virtual threads. So if you're on Spring Boot 3.2, JDK 21, we could take advantage of virtual threads and really solve some problems when we're making a lot of those calls. So we'll take a look at an example today. I don't want to start from scratch because I don't want to make this more about building out your first GraphQL API. I want to make this more about kind of these performance improvements that we can make in here. But my plan is to take a lot of what we're going to cover today, but a lot of what I've been doing with GraphQL, and turn this into my next YouTube course. So I want to build a full masterclass on building GraphQL APIs in Java. If that is something you are interested, do a couple of things. One, let me know in the comments below if you're interested in what you would like to see in that course. Also, head over to danvega.dev, sign up for my free newsletter, and I'll let you know when that one is on its way. For today, we're going to be working with this GitHub repo, github.com/danvega/GraphQL books. This is the one that I used in the conference presentation. This has a lot more code in it, but it does have the example that we're going to walk through today. And again, this will probably be the basis for what I'm going to cover in the course. So with that, I'm going to go over and show some code. I'm going to get me out of the way here so we can take a look at this. Let's talk about what is happening in this application currently. Just a normal Spring Boot application from a pom.xml standpoint, from a dependency standpoint. We have the actuator. We are using Spring Data JPA. We have we have included GraphQL. This is a web project. I have Zipkin included so that we can take a look at some observability and kind of see what's happening in the system. We have our dev tools. We have Docker Compose. Because we are using Postgres and that Zipkin, we automatically get those services for us. So when we run this application, these services are started automatically for me. So that's that. From a application configuration standpoint, we are using JPA. We are automatically creating and dropping the schema every single time, just because it's a demo. And we are showing some SQL because I want to see that SQL in the console to identify a couple things. So we have an author and a book in this system. A book is an entity. It has an ID, a title, and an author. The author has an ID, name, and a one-to-many collection to books. And so this will be important when we take a look at some performance optimizations that we can make. So each of these are in their own package. We have an author repository. We have a book repository. These are just extending JPA repository. The author repository extends JPA repository as well. We also have this data loader. So this is going to, on startup, go ahead and load some authors and books. Some of my good friends here, Josh Long, Mark Heckler, Greg Turnquist, some of my favorite books we're loading into the collection. So if we ask for all the books, we'll get those. So this is a really good starting point. Oh, let's look at the GraphQL schema first. I've stripped this down to just book and author. And then we have a couple of queries in here. One to get all the books, one to get a single book. So if we look at the book controller, we have a way to get all the books that uses the repositories find all method. We have a way to get a single book. We also have a way to add a book, but I don't have that set up here in this mapping. But that is essentially what we're starting with. So what I'm going to do is run the application, and we'll take a look at like how we can get a list of books first. and then we'll build out some authors, and this will kind of point out some of the things that's going on that I want to improve upon. So here's my query. I'm going to get a list of books, ID, title, and then the author. I want to get the author's name. And if we do that, we get all of the data that we're expecting to come back. So that's our starting point. I want to take a look at authors because we don't have authors in here. So we have this author object type, but we don't have a way to get a list of authors. And so I want to do that. In GraphQL, we start from a schema standpoint first. So we're schema first. So I want to go ahead and say I want a way to get a list of authors. And that is going to return back an author that is not going to be null, and this collection is not going to be null. So based on this kind of gutter icon here, you can see we don't have the Java implementation set up yet. That's okay. We start with the schema, then we work on the implementation. So what I want to do is go ahead and create a new Java class in here called the author controller. And the author controller is going to be a controller. We're going to need a few things in here. The first thing that I'm going to need is a logger. So I'm going to get a logger. I also want that author repository to say get a list of authors. So I'll call that author repository, and we'll get that through constructor injection. So I'm going to set up my mapping. I'm going to use the @query mapping annotation. We'll say that this is going to return a list of authors. We'll call this authors because we called it that in our schema. And as we type that out, you see immediately I get this gutter icon letting me know that now I have something set up. And you can see that in the schema as well. So we are on the right path for this. I want to go ahead and log something here. I'm going to just say that the author controller dot authors method was called. That'll be important for seeing what's going on here in our controller. And all I'm going to do is return the author repositories find all method. All right. So now when we ask for a list of authors, we have this one-to-many collection with books. We should get a list of all of the books for that author. And again, if we go back to the data, just in case you aren't familiar with the data, we have 3 authors in here. I think one has multiple books and the rest have just one book. So let's go ahead and rerun our application. And what I want to do now is go over to graphical. Again, I've enabled that in my configuration. And what I want to do is ask for a collection of authors. So instead of this query, now I'll go ahead and say authors. And in authors, I want the ID and I want the name. And then I want a collection of books for that particular author. From a book standpoint, I want the ID and I want the title. So if I go ahead and run this, you see everything comes back. We have our authors. Here's Josh with his book. Here's Mark with his book. Here's Greg with his 2 books. What I want to do now is head over to the console because we are logging out this SQL. And I want to see this here. Basically, I select from author. So I get all of the authors. And then you see there are 3 calls to my database for books. And that's because I have 3 separate authors in there. And we are making a call for every single author to get the author's books. I don't know if my log is in here. Let's see here. There's that. Author controllers authors was called. So there's our author controllers authors being called. And then there's our ones to select all from authors. And then for every author, we're making a call to the database to get the collection of books. So right away, this is an N+1 problem that we can fix from just a SQL standpoint, right? So right now, we are calling this author repositories find all method. We can kind of clean this up. So let's go into the author repository, and I'm going to add a new method here that returns a list of authors. And I'm going to say I want to find all with books, right? So I'm going to find all the authors with their books. And I'm going to use a custom query here. Custom query. And all we're going to say here is select A from author A. And I want to left join fetch a.books, right? So now we want to use this query method instead of the find all. So let's just comment that out and then say return author repository dot find all with books. And let's go ahead and rerun our application and see what happens here. Okay, so we're going to go ahead and run this again. Again, all of our data comes back. But now if we look in our logs here, we see the author controllers, authors was called. But now I have only single query. And this is important because in this example, we only had 3 particular authors, and it went out and got books for those 3 authors. But what if we had 100 authors? And that was just like one call to that. And then we have, 100 invocations of that from a request standpoint. This is a lot of strain on the application that we do not want. So we want to make sure we're thinking of these things. So this is one way to kind of fix the N+1 problem from just a query standpoint. So we fixed it from the database standpoint. But let's take a look at like another kind of scenario that we might run into. Okay, so I'm going to comment this out. We're not going to use this one. We're going to create another one. Now, right now, we have this data fetcher is basically registered for books, so that when we get books, this one-to-many association inside of Hibernate here is called, and we get a list of books for that particular author. But what I want to do is maybe, what if that wasn't the case? What if we were getting books from maybe another service somewhere, a microservice within our organization? This is something that happens often, right? We get an author, and then we may call to another service to fetch a collection of books. So let's do that. Let's say we have public list of book, and we'll call this books with delay. I want to do this on purpose, and this will take the author. The author is the parent, and what I want to do is just log some info here and say retrieving books for author, and then we'll say author.name. And so now we know who we're retrieving books for. I'll do a quick thread.sleep, just 1,000 milliseconds or 1 second. And then I'll go ahead and return a new array list. I don't care. It's just an empty collection of books is fine. And then we'll add this. And now this books, and actually I want to call this books, right? So I want to call this books so that we override that data fetcher. And then we'll say at schema mapping. And now we see that as registered to books. We see this overrides the normal JPA method, and we're now using that as the data fetcher. So now when we call this, what's going to happen is we are going to retrieve the book for the author. We're going to sleep for a second and then just kind of return an empty collection. And as you can imagine, we have 3 authors in the system. So for every author, we're going to make a call to that. Authors was declared non-null. That's okay. We can kind of fix that. So that might be null. Books, I bet, is not null. Let's just rerun that. Let me see what that error was saying. The field path authors was declared non-null type, but the code involved returning data returnly. Although, okay, so it's saying the author was returned non-null, but the author should be returned. That's strange. So, let's see here. Now the author should come back. It's just the books association that we've set up here. Oh, okay. So we still need this. So let's go back to this. Sorry, I forgot. make sure I saved that. I forgot that we kind of took this out. Let's take that out. We don't need this anymore. We can use this. Because again, we're just going to get the authors. We're not actually going to get that book association because we've registered a data fetcher for books. So it doesn't actually call the internal one-to-many mapping. Okay, so let's see if that fixes our issue. Okay, so let's run this. And you'll see that this will take about 3 seconds. So we get, for each author, we get an empty collection of books. And if we look in the console here, we can see that author controller authors was called, but then we can see for each author, we are retrieving books for that particular author. So again, this is the N+1 problem. This is something we want to pay attention to. If this is happening in our system, even if it's at this small level, 3 authors go get 3 collections of books, not a huge deal, but we know that at some point this is probably going to scale. If it's at 100 and 100 people are requesting this API at the same time, that is a lot of invocations, right? That is a lot of things. And on top of that, this is 100 invocations of this particular controller mapping, right? So big deal that we need to be able to recognize this and solve for this. So couple things that we can do to solve for this. First off, one, if we look at the logs here, we can see that we are running on the same thread for every single request. So something that tells me this right away is, hey, what if we moved over to virtual threads? Now we're not executing on the same Tomcat thread. We could at least execute on separate threads for each of these requests and cut down on some of that time here. So I can go into application.yaml and we can enable virtual threads. Virtual threads enabled equals true. And let's go ahead and rerun this. All right, we'll run this query again. And you see that was a little bit quicker. That wasn't quite 3 seconds. That was a little bit quicker. And if we look in the logs, we are indeed running on different threads now. These are using virtual threads. Lightweight, faster, and you're able to kind of spawn multiple of them, almost giving you that illusion of kind of infinite scalability. So that was much quicker just by enabling virtual threads. Now, I want to kind of take that out because I want to do one more thing. You know, we were kind of able to notice that this was an N+1 problem because we were staring at the console on our development machine and we saw like the SQL that's running and some log statements. This isn't always the case in another system, right? In a test environment, in a production environment. And this is where observability really comes in handy, especially in GraphQL. GraphQL lends itself to observability really well, right? Because we may use different data sources to go get data. We may talk to a database. We may talk to a cache, a local file, another service in our organization. So we're fanning out, we're spawning out to these different services to get data. And we need some observability on that to see what's happening underneath the hood. So I mentioned we included the Spring Boot actuator. That's all we need to start collecting some of these metrics. The one thing that I included was Zipkin to kind of expose some of those span and trace IDs. So with the application running, I'm going to make this call again. That should take 3 seconds. This time I'm going to go over to 9411, which is what Zipkin's running on. And let's see if we can run this query. Now I don't have the samplers like for every single time. So let's see if we get one here. Should probably change that. Because again, by default, we aren't collecting metrics on every single request. That would kind of slow things down. We're doing it on a number of requests, but we should get one here that we can go ahead and take a look at. All right, and there is our request. So now in our observability tools here like Zipkin, I can go ahead and drill down into this particular request. I can say, show me more about that. And as you can see, we have a GraphQL query to books for the field authors. And then you see for the field authors, we have 3 separate calls to books, and each of those are taking a second. So again, in our scenario where maybe we had 100 authors, we would see 100 of these, and we'd see them all taking a second. Now we could start to figure some things out. One, is that second call an issue? Maybe it's not, maybe it is. We could probably figure that out. But 2, we have 100 calls for each author, right? Or we have a call for each author. That's probably not a good thing to do. Let's go ahead and correct that N+1 problem. So observability really key in kind of giving us some insights into some of the problems that we are going to face. Okay, so what I want to do now is I want to get rid of this. Let's just go ahead and get rid of that. And I want to see like how we can go ahead and correct this problem so that we're not making those N+1 problems. And this is where the @batch mapping annotation comes into play in GraphQL, allowing us to kind of solve for this. So what we're going to return is a list of books, right? So we're returning a list of books. And we'll call this books. And we are going to say, we're going to get a list of authors, and we'll get a list of authors like that. So now that we get a list of authors, we're going to get one controller invocation for that books. Instead of, hey, here is an author, for every single author, call this books one. No, we're going to call just, once we collect all the authors in the system that we care about, as far as this goes, we're going to call this books method one time. So now that saves us from calling this method 3 times, right? Or 100 times in the bad scenario case, right? So what I want to do is just log that out. So I want to say log.info. What we'll say is batch loading books for authors, and we'll say authors dot size. I just want to see how many authors we're loading there. So we're going to load those out. Now what I want to do is get a list of author IDs. So let's say a list of longs. We'll call this author IDs. And the way that we'll do that is we'll get a list of authors, we'll stream them, and we'll say, let's go ahead and map that. So we'll get an author, so we'll get their ID, and we're going to map that, and we're just going to return a list. So now we have a list of author IDs. And what that allows us to do is now say, hey, in the book repository, and that IntelliJ is awesome. It just went and added that dependency for me. I want to go ahead and find by author IDs in. So this is a custom method in that repository that I have that is going to take a list of author IDs and return a list of books, right? So that is very handy. That can create a list of books. We'll call this all books, right? And now we have a list of books. Oh, but we need some author IDs. Let's go ahead and pass that in. All right, so now that we have a list of books, what we can do is we can go ahead and group books by author ID. So how do we do that? Let's get all the books, let's stream them, and let's go ahead and collect them. So we'll use the collectors.groupingBy function, and what we'll take in there is a book.getAuthor.getID, and that should do that. So what we'll do, so that is going to return a map of a long and a list of books. Call this books by author ID. Yep. Okay, so we're almost done. Now what we can do is just return authors.stream.map, and I can get in the author here. And from the author, I can say books by author ID .get or default. And then let's just say, oops, we need the author .get ID, right? And then I also need just a collections.empty list if that is nothing there. So that looks good. And then I just want to turn that into a list, and that should be it. So now we are using this batch mapping in place of the normal schema mapping. So this batch mapping says, hey, don't call this method invocation one time or every time for every author. What I want you to do is collect all of the authors and then pass that list of authors to this method one single time. And then because we have that list of authors, we can do some things here to get a list of books, and that will return everything. So let's see if we can rerun the application. And then what I want to do is really just call that same authors query in our graphical UI there. And when we get a list of books, we should only call this one time and get all of the books for that. So let's go ahead and run the same query. You see that was really, really fast. We see that we are batch loading for 3 authors, and then we end up really just making this one call to the database. Again, in this case, it's to the database, but this could easily have been a call to another microservice to kind of get that information. On the other side, we could pass in all of the authors, get one single call to return all of those books, and then just return those books as a list of books. So that is batch mapping. All right, so those are a couple really good optimizations we can make when building out GraphQL APIs. Make sure you're paying attention for the N+1 problem, really in any application that you're building, right? Starting with JPA, if you have this one-to-many association, that's something you want to be thinking about. You can do some things on the association to say, hey, I don't want to lazily load these. I want to eagerly fetch all of these. But there are also ways that you can create your own queries to make sure that we're doing that join and not getting a list of books for every single author. So that was from kind of the database side of things. But then we also looked at, okay, if we need to make a method invocation for every single author, how can we correct that? And so we took a look at a couple things. One, taking advantage of virtual threads, so we're not running on the same Tomcat thread for every process. Now we're spawning virtual threads fast, lightweight, and we sped that up pretty quickly just by taking advantage of that, turning that on in JDK 21 and Spring Boot 3.2. The other thing is taking a look at observability, being able to notice those things in the logs, being able to spot those things and correct them. So what we spotted that in our logs, in our observability, and we said, okay, how can we fix this? So we took advantage of the batch mapping annotation in Spring for GraphQL. That allowed us to stop calling that thing every single time for every author that we needed to get a collection of books on. And now, whether we are reading from a database or calling some other service, we're only going to make that invocation once, and we can get all of those things at one time instead of having to do this every single time. These are some of the performance things that you really want to pay attention to because they can make or break your application. Your users saying everything is too slow. Again, when we start to scale this pretty big, that's even going to compound the problem. So these are some things we definitely want to look out for. So, hey, if you're building GraphQL APIs, again, if you're interested, I'm going to build out a course on GraphQL, a full kind of masterclass. Let me know below if you're interested in it and what you want to see covered in that. But if you're building out GraphQL APIs, I hope you found this useful. I hope this is something now you can kind of look out for in your own APIs. And I hope you learned something new today. If you did, friends, do me a favor, leave me a thumbs up, subscribe to the channel, and as always, happy coding.